Okay, this is the P4 paper from January 2021. This is question number 3. You can see it's a proof by contradiction question. Now this question is only worth 2 marks, so it's a quite quick thing to do, but I'm going to take a little bit of time just to remind you about proofs. They're relatively new to the syllabus, and I know a lot of my students don't like these style of questions. So with a fairly straightforward one like this, we can just remind ourselves of the steps of what we're trying to do. So in this case, it says, prove by contradiction that there is no greatest odd integer. So if that's the situation, then the first thing I'm going to do is try and assume something that I know won't work. So my assumption, they sometimes call this the negation assumption, or the opposite. I'm going to assume there is a greatest odd integer. There is a greatest odd integer. Now, integer. Now you can call it n. If you want to say it's odd, call it 2k plus what? 2n plus 1. In fact, I'm going to do that. You don't actually need to call it 2n plus 1, but I'm going to say there is an integer 2n plus 1. Well, if that's true, what I'm then going to do is say, okay, if that's true, let k be equal to 2n plus 1 plus 2. K now becomes 2n plus 3, and the two things we know about k is odd and k is greater than 2n plus 1. So my assumption has failed. Therefore, the assumption is false, and so the original thing I was trying to show, therefore there is no greatest odd integer. Let's just go through that again slowly then, and just make it clear what we try and do when we've got the question. So as soon as I have this as my attempted proof, show there's no greatest odd integer, I do the opposite. I assume, and the true version, the opposite version of what I've got there. Once I've done that, all I do is I go through a process now where I get to a situation where what I was trying to assume breaks down. So at that point when it breaks down, I always finish pretty much with the same thing. My assumption was false. If my assumption was false, then the opposite of that is true, and the opposite of that is true, which is what I was trying to prove. So only a silly little question there, but hopefully that's given you another reminder of the steps that we do if we're trying to solve one of these questions. Hopefully that makes things a little bit simpler for you.